Okay, it's 9 o'clock. And so, yeah, I'll give you a little bit of a briefing. Probably next Thursday, detailed briefing on exam 1. Get your clickers ready. We're going to do a bunch of clicking. And again, I'm going to show you a different method of clicking today. It's similar to the numerical clicking that we did on Thursday, but it's going to be alphanumeric input. You're going to be typing in letters and making words and stuff. But before we do that, we have some organizational information. And let's just make one thing clear. UCF is the national champ. I was looking at this Coley matrix, and notice what it says there. Bias-free matrix rankings. All right, and when I looked at it, this is what I saw. UCF number 1. So let's just stop fooling around. UCF is at the top. These other posers, they're out of here. So just please, all those folks over, of course, we better be nice. Otherwise, they'll start crying like Tom Brady, you know, crying for a penalty flag or something. If you don't give them the business. Anyways, let's talk about regular stuff now. iClicker. I synchronized the roster once. I'll synchronize it again about 15, 20 minutes after lecture. And if you are registered by that time, you'll get a bonus point. Now, a bunch of you already got your bonus point last week from being registered by Thursday. It actually a little bit past class time before I synchronized it and gave points, bonus points. So if you got that, Thursday, you're getting another one today, because if you're registered last Thursday, you're automatically registered today. So you start off with some bonus points. You have an A+ for the semester, at least for the next week or so. Anyways, if you don't get the bonus points, don't sweat it, because what I want you to sweat is get registered for Thursday, okay? Because that's when the official participation starts. So get it registered by Thursday, and only in web courses. Now that little link there that you can see on our homepage, yeah, that's where we want to register it. You must not use iClicker.com, because it discombobulates everything, and you're basically out there in the ozone layer somewhere, who knows. And I've had students, they just, for whatever reason, they don't get the message to only use web courses, or only use web courses. And then by the end of the semester, Dr. B, where's all my participation points? It's too late to get anything done then. So do that. It takes about 2 seconds. It works pretty good. All right, another thing I want to mention to you, and this is also kind of related to iClickers in a way. A student asked me about where to get an iClicker, and I said, well, post your question in discussions, and then people will help you out that actually know. And when you're in discussions, this is what it looks like when you start a new, actually this is what the student's thread looks like. And I want to draw your attention to this set of options down here. Here's a close-up of them. I want you to select, no matter what you post, if it's a question about the moon or the supernova or your iClicker, select threaded replies, and then also allow liking. And the reason I ask you to do that is it makes it more efficient for people to follow. If there's any kind of a complicated discussion, if it's not threaded and if there's no liking, it can be hard to follow. Similarly, up here at the top, when you type in the title, make it really descriptive. Don't just say, please help me. That's, it's not that I don't want to help you. It's that, if somebody else wants to help you and they know what you're asking about, like iClickers, then instead of just some generic, please help me, they'll be able to help you a little bit more efficiently. So all those things will help discussions work efficiently. By the way, did anybody buy an iClicker today? Where did you buy it?
The bookstore.
The bookstore?
Yeah.
What? The bookstore actually has, because I heard yesterday that they were out.
Yeah, I got one.
Yeah, all right. Did they have a lot?
Oh, I don't know.
Yeah, okay. Anybody else? Did anybody get one at the bookstore yesterday? All right. All right, well, maybe the bookstore is the way to go. It's kind of shaky. Do they still have that C and B bookstore over across the... Are there any other bookstores near campus?
The one on the Breezeway.
The Breezeway?
That's the only one.
You mean
That's where I got it.
the UCF bookstore? There's a UCF bookstore down by the arena too. Is that where you got it, at the arena, or John T. Washington? All right. How about you?
I got it at John T. Washington.
All right. Anybody been over to the arena bookstore? Do they actually have them over there? Anybody buy one from the arena bookstore? It burns and I think a bunch of you guys have gotten them from Amazon. Okay. Hopefully you get it in time for clicking on Thursday. It always makes me nervous thinking about that. Anyway, so that's a little bit of organizational help on iClickers. Anyway, so when you're posting questions on any topic in discussion, I want you to remember that anything is appropriate there except your personal grade information. So don't post, if you have something about your exam grade, for instance, don't post it in discussions. But if it's something like, Dr. B, what page was that you were referring to? You can actually post that in discussions, and your classmates, or Jenny, or I can help you get that sorted out. No phone numbers either. Jenny, if you ever see that, students posting phone numbers, just delete it. And I'll delete it too. We don't want that. All right. And I know that you guys are pretty free with your phone numbers, but it's just not appropriate. If you want to get your phone number to somebody, and kind of network with them and stuff like that, do it on messaging. Don't do it in discussions. All right. I'm not saying that there's any maniacs in this class, but I'm just saying. Okay. So again, check the allow threaded replies, allow liking, and make the title descriptive. All right. And I try to do the same thing as well. So remember that things will be, and discussions, in case you're wondering, discussions can be a really helpful, almost like a virtual study group, virtual study partner. Although I know that the GroupMe thing is going, there's all kinds of other things to do. But anyways, discussions can be pretty helpful, specifically because Jenny and I are in there, and we're experts, and so we can answer most of your questions. Okay, here's the basic layout prior to exam 1. In terms of readings, the introduction, chapter 1, up through about chapter 1.6, which we're going to be finishing today. And then for the next 3 lectures, Thursday and then next week, 2 lectures next week, a little bit of chapter 2, a little bit of chapter 3, and we're going to dip ahead into chapter 19.2, hopefully by the time we're done with class next Thursday. And the chapter 19.2 is going to bring it all together because we're going to be we're going to be talking about black holes today. The black hole that we talk about today, we'll be talking about next Thursday, and I'll probably be asking you questions about it on exam 1. Just the basic stuff like, triangulation and orbits and stuff like that we're going to be talking about next 3 lectures. Anyway, so that's a little bit of reading ahead, mental guidance for you. Let me pause for questions. And just to remind you, all the lectures are recorded, and that's why actually, you know what? This one's not being recorded yet. Let me. Okay. As I was saying, we record the lectures, and so if you're absent, you can always catch up. And I see, occasionally I see people taking photos with their phones and stuff, which is nice. But you don't have to, because it's all going to be on YouTube, 720p, which is pretty good resolution. And I usually do it right after class. So, all right, clickers, get them ready, get them turned on. Let's switch to short answer. And we're going to do some special clicker techniques today. We're going to be typing in for the first 3 questions some words and some symbols. So what you're going to do is use the up and down arrow keys to select a letter, just as last time you used up and down arrow keys to select numbers. And then you're going to use the right arrow key to go to the right and type in another letter. And you can use the left arrow key to go back and type in a different letter if you change your mind. And then when your string of letters is complete, you're going to hit the send key. Now, this particular, go ahead and start it. We're on, go ahead and show this. Go to the, okay, for those of you that are using your clicker for the first time, follow this method here. Press and hold your power button until it flashes. Okay, and then type in DD. All right, and then you'll get the message Go Nitro, and then ready. All right, and if you're sharing your iClicker with your roommate or something, you're going to have to do this every day when you come to class, because unless their instructors also use a DD, but it could be any number of other combinations. All right, so base frequency DD. Okay, switch back to the laptop, please. Thank you. All right, now I want you to hit the refresh key. Okay, and you should get. You should have the letter A. Raise your hand if you have the letter A. Okay, when you're doing a short answer question like this, it starts you on the letter A. Okay, and then you select what you want. Now, the first question, pretty cinchy. Just type in your middle name for practice. Remember, these are practice questions. So up and down arrows to find a key, to find a letter. Listen to that. The sound of clicking. You don't have a middle name? Type in Bob. B-O-B. Just for practice. I mean, it's not like I'm going to grade you on your... If you don't spell your middle name right, I won't know. So we're just going to give everybody correct on this. So if you... Type in Bob. If you don't have a middle name, type in Bob. Did you know that President Harry S. Truman, from 70 years ago, he did not have a middle name. His middle initial was S, but it didn't stand for anything. It was just S. I guess his parents were a little bit cranky on the day he got baptized or something. All right, let's take a look at the... I see Abby. I see somebody typed in 0. Oh, I don't know. Sometimes, let's go down and look at this. I don't know if I'm getting through to you guys. Yeah. Adelina, Brianna. It's kind of hard to... Actually, we can see... go to the top of the list. Let's see what's up top. Alejandra. It's kind of hard to see. All right, I'll give you 1 minute to actually, I'll give you 15 seconds to finish for those of you that have really long names. 10, 9, 8, 7, 6, 5. Remember to press the send key. All right, if you don't press the send key, I don't have anything. 4, 3, 2, 1, 0. Okay, click that. All right, switch to auxiliary power. All right, let's take a look at the results chart. Can you make it full screen? All right, let's take a look at what we got here. Okay, Abby, Abnel, Adelina, Mr. Zero. That's all right. Alex, Alfonso, Angle, and let's see if we can find out. BDDD, Buddy. Bob, we got 11 Bobs. Somebody's middle name is Bomb? What? All right, go down to the bottom. See if you can get down to the bottom. Let's see the bottom of the list here. Yeah, let's see if I can scroll it here. It's hard to scroll this thing. It's a menace to navigation. Doug. Diane. Curtis. This is good. Anyway, so, okay, that's good enough. This scroll bar is really tough to work on for some reason. Okay, tile it. Okay, great. And bring it back to the laptop. Okay, so that's an example of just typing in a word. All right. So what we're going to do now is type in a little bit more difficult task. You're going to use a code table to type in a sentence. All right. Now here's the code table, and there's an example. ZATRWO means zombies always take revenge with Oreos. Now this is kind of a goofy one, so just type in any sentence you want. Go ahead and start a new question. And we'll try to look at some of your answers and see what. And if you haven't figured it out, I made all the code is the first letter of each word. So chickens, dinosaurs. Oh boy, listen to all that clicking. All right, now this one is also a practice question, so you know everybody's you can start clicking correct if you want. Whoa, here's a long one. I think the limit to the symbols is 14, but you don't have to write a sonnet or anything like that. So just something that indicates that you're a sentient being. It's hard. Maybe this thing is what you want.
No.
No.
This isn't working again. Or maybe it is. I just don't know.
Yeah, this is working. All right, just type to the right, hit the right arrow key, and then select another letter. Okay, with the up and down arrow keys, you're good. Okay, 30 seconds to get in your top secret code sentence. So I want to see how many people select something. About zombies. See, because we can make correlations in the data here. That's the whole thing about this. Okay, 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, go to this auxiliary power. Okay. Ooh, look at this. Whoa! Zombies are B. Let's look at ZLCA. ZLCA. Zombies love chicken always, I guess. ZLC. Zombies love chicken. ZLA. Move this up. This thing out of the way. ZLAEWD. What is that? There's a lot of zombies here. Nice. Zombies love always eat with dinosaurs. Nice. Zombies and dinosaurs. That's the RW. Oh, that's what I did. ZEMK. What's that? Zombies eat many crinkle cut fries. Nice. All right, so that's good. Go ahead and tile that. All right, so these are, kind of interesting results. Now, here we're going to do the same thing, but a serious astronomy question. All right, it's actually based on the reading. All right, and this is why we did the previous two questions, goofing around with stuff, but now a serious question. Here we go. Create a sentence about the laws of nature from this code table. All right. Did I give you an eye clicker to use? Mm-hmm. And the nice thing about these, when you're typing in something like this in class or on a test, I convert your code, the string of letters that you send, don't forget the send key. I convert that into a sentence. I reconvert it out into a sentence because I have the key. And I read everybody's sentence. And it won't be the most, it's not going to be like Shakespeare or, or even Harry S. Truman for graceful words, but I'll be able to understand what you're saying, hopefully. All right, and again, when I do this on an exam, as I sometimes do, I'll be able to give partial credit. And this would be like a 3 or even a 4-point question on the exam. And so you would have, full points would be like maybe 4 points, partial credit 3, 2, 1 points. So depending on how I like your sentence and how complex the question is. The other thing about this is that it's a subtle difference, but yet it's powerful. You are actually creating a correct answer, hopefully. On a regular multiple choice test, and you'll have a bunch of multiple choice questions, I write the answer. Think about it. I write the question, and options A, B, C, D, and E. I write the correct answer in there somewhere, and I write some wrong answers to try to trip you up. So you select the right answer. But I control all of that. You're dancing to my music, right? This kind of question, you're telling me what the right answer is. And, if there's 300 people in here, there could be 300 correct answers, all of them different. Although maybe not on this one, but on other questions where you have a pretty good code table, yeah, there's a lot of freedom. So this is, I can still hear you guys thinking. See that clicking? To me, that's the sound of thinking. And you know what, guys? You should make this your first astronomy notes of the day. Your answer to this. Go ahead and write down your answer, the code, and also the actual sentence. You're creating a true sentence about the laws of nature. And yeah, there's some good ones in here. laws. Yeah. All right, let me give you one more minute. And just so you know, this is these words are actually straight out of chapter 1.3. I selected a couple paragraphs. I stripped out the thes and the a's, and I kept a lot of the words from a couple paragraphs in 1.3. The ones that were I counted them all by frequency, and I gave you the popular words from a couple paragraphs in chapter 1.3. Okay, 30 seconds. I hear almost everybody done. Okay. Now, remember, this is a practice question today, but starting Thursday, if I ask you a question like this, it'll be for real, and it'll count toward your participation grade. All right? By the way, on these questions, okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, go to the auxiliary power. All right, let's take a look at some of these answers. ACLTZ. One person sent that in. Laws that apply to nature. That's not bad. It's not a sentence, but it doesn't have a verb in it, but that's all right. Let's see. AKZNPF. Can you go down a little bit? All right, just leave it there then. AKZNPF. Laws about nature, NPF, can determine rules. Okay, that's not bad. ALBZ. Laws apply in nature. All right, that's good. See if you get me one more bunch. Let's take a look at this one at the bottom. AOZLTJ. Laws. Everybody's starting with the letter. See, you know what? That's significant. The fact that, the previous question, there were a lot of strings that started with the letter Z. So all you guys are thinking about zombies. This one, you're looking at this thing and you're all thinking about laws instead of nature. For the first one. AOZLTJs. And that's significant. So these are interesting. Okay, here we go. AOZLTJ. Laws of nature apply to us. Us. That's not bad. Okay. Tile it and switch back to warp drive from auxiliary power. Okay. All right, so that's good. And just to remind you that that's related to chapter 1.3 about laws of nature. Now, I'm going to ask you another question here. This one's going to be multiple choice, so hit your refresh key again. And this one's going to be about the reading as well, so hopefully you'll get the idea that when I give you a reading assignment, I'm going to ask you at least one or two questions. I didn't ask for you to type in the letter A yet, or B or C or anything. What are you guys doing? You don't even know the question. All right, here's the question. Reading check. If the sun were the size of a basketball, as mentioned in your reading, 1.6, etc., etc., etc. Right. Good. All right, now this one has one correct answer. If you didn't do your reading, give it your best guess. Now we're gonna actually let's mark off them correct for today. On a test, there would be this one it's okay. Just mark that, leave that one. Okay, on a test, you know, we'd be looking for one correct answer, but give it your best shot. All right, 15 seconds to vote. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, go ahead and show the auxiliary display. All right, so look at this. All right, what this tells me is that not a whole lot of you guys remember the answer to that. If you did the reading, you don't remember it. The correct answer is C. Go ahead back to laptop, but there's no spike. You know, not everybody answered that. Go ahead and make a note of that. Yeah, 7,000 kilometers away, like Rio, down in Brazil. So if the sun were the size of a basketball, think about it. I mean, if you scale down the sun to the size of a basketball that you could hold in your hands, then Alpha Centauri or Proxima Centauri, the closest star would be another basketball down in Rio. And because they're both extremely hot, thousands of degrees, and they're really big, we can actually see the light from Proxima Centauri. And actually, Proxima Centauri is kind of pokey. It's not very bright, but with a telescope you can see it. Naked eye, you can't really see it. All right, now let's take a look at this. I want to go through this with you. And, I don't know how you can take notes on this, but this is from a website called gpsvisualizer.com that I like to use. Everything on this red line is 7,000 miles from Orlando International. So like here's Rio down here, 7,000 kilometers away. Here's Santiago in Chile. Over here, that's about 7,000 kilometers, slightly different direction. But you know what's kind of cool about that? You think Chile, the Pacific Ocean, west, you always think west to the Pacific Ocean. But actually, that's way east of Orlando, significantly east of Orlando. It's kind of cool. Dakar, Senegal, over here in Africa. Madrid in Spain, about 7,000 kilometers. London, England, about 700 or 7,000 kilometers from Orlando. And all the way over here in Alaska, Nome, Alaska, 7,000 kilometers. All right, so everything on there. So think of a basketball in Nome, Alaska. That's what we're looking at. It's glowing. It's a few thousand degrees temperature at its surface. And we can see it with a good telescope, Now here's another look. This is what we call an azimuthal map, slightly different than what you just saw. Oh my goodness. The doctor's office is calling me. Azimuthal map, yeah, so this one shows everything that's 7,000 kilometers from MCO. MCO is right at the center of this, and this is the website you can use to look at it. Here's the blow up of it. Okay, and here's London up here, Madrid over at this edge of the map. Here's Dakar, Senegal, Rio. Here's Santiago de Chile, and up here is Nome, Alaska. So that's another way of looking at it. And I hope thinking about this basketball proportion, which is also in chapter 1.6, gives you an idea of just how big the distances are. It's hard to savvy, the distances and the sizes in true proportions. Now, I'm going to show you another example from 1.6, and this is the Earth to moon to scale. So make a note, figure 2. chapter 1, section 6, Earth and Moon. And this is to scale, all right? Now, in this picture, here comes the Earth. Now, I'm moving it to the left, and the moon hasn't come into view yet, but it's just kind of poking along. Come on, baby. Come on, moon. Moon. Yo, moon. Get in there. Come on. There we go. There's the moon. Want to see that again? Here you go. All right, so this is the moon. Here we go. Come on, moon. Good night, moon. Good morning, moon. As soon as you get here. Did you ever read that when you were a little kid? Good night, moon. I didn't have that when I was a little kid. Here it is, all in one look. It's amazing. You know, if you look in a lot of astronomy books, or, you know, like the newspaper, you know, they show, you know, the or a spacecraft going to the moon. The moon, you know, they make the Earth like this, and they make the moon the right size, but they're like right next to each other. This is how they really look. If the Earth were, here's another, you can make a note of this in your notes. It's not in the slides. If you took a regular classroom globe of the Earth, you know, one of those ones that spin, you know, it's on a little base, you have it in your 6th grade classroom, and, you know, but the teacher has to keep it on her desk so that nobody messes around with it and stuff. You know, it's about this big, maybe 12 inches across. If you took that globe of the Earth, then the moon would be like a tennis ball about 27 feet away. Right? That's this proportion. And it is very tough. You know, the guy, if you were the editor of the New York Times, you know, and your editorial cartoonist or your editorial artist came in with this diagram, he'd send you back to the drawing board, man. I can't use this picture. But that's what it is. It's very drastic. Now, I want to talk about Earth to Sun distance. Okay, so here's some more comments from 1.6. We call the Earth to Sun distance an astronomical unit, abbreviated AU. And the reason for that, in the days of like Copernicus, Aristotle and Archimedes, those cats, they did not know, you know, they didn't have the speed of light. They didn't know the timing, you know, of light. They couldn't measure in light seconds or light years or anything like that. But they could figure out the proportions, you know, so if the Earth's diameter is something, then they can, and so they based everything on the astronomical unit, 93 million miles. It's about 500 light seconds. It's like 499 point something light seconds. Now a light second, you'll be able to read about in chapter 19, and actually not section 19.1. You'll be able to just go through the basics of a light second. It's basically 3 times 10 to the 8 meters. That's 300 million meters, 300,000 kilometers in 1 second. So that's most of the way to the moon, a good fraction of the way to the moon in 1 second. So 500 of those, and you get to the sun. So they had to do a lot of calculations back in those days, but they had to do it all in proportions. You know, and the proportion was based on the Earth to Sun distance being 1. Question?
Can I move that?
You certainly may. Actually, Jenny, can you move that? Just slide it over in front of we'll have Jenny slide it for you. It's kind of a novelty. You know, did you realize that you better not trifle with the screen. It's still obscuring part of the screen. Did you know that most lecture halls in campus, like over in Classroom Building 2, they don't even have a marker board. They just have the computer displays. This just has one. All right. Anyways, we did not really have a distance. We couldn't triangulate. They could triangulate distances to the sun, to the moon and stuff, but they didn't actually know how many miles that was. They didn't know how many light seconds. They didn't know how many kilometers. And we didn't really triangulate our way out to a star until about 179 years ago. Friedrich Bessel triangulated 61 Cygni, which is in the constellation Cygnus, the Swan. It's about 10.3 light years away. It's close enough, bright enough, that we can see a difference in the position between June and December for that particular star. And he's pretty famous for having done that. But before we were able to do any of that stuff, in other words, before we could do any trig and know the actual distance in miles, we had to do everything in proportions, which is all right. By the way, this image here of the sun in ultraviolet, that's actually the atmosphere of the sun, the heliosphere they call it. Millions of degrees temperature, where it's bright, light blue. And you can look at those images. They're from the SOHO spacecraft. It's orbiting the sun and constantly taking pictures and beaming them back to Earth. Here's the website for that set of images. And here's the general address, SOHO, www.nascom.nasa.gov. It's a pretty nice website. And actually, in your homework assignment for tonight, I put a few links at the bottom of the homework, so don't worry about having to copy this. Question? No? Okay. All right, let's keep going. Now, another thing that I want to take issue with in the textbook, they define a planet as, and I was reading that, and I said, whoa, not so fast, because the definition of planet was redefined back in 2006, International Astronomical Union Resolution B5 at some meeting. So like a bunch of eggheads meeting and talking about planets and stuff. And there's the website. And that's the famous meeting in 2006 where Pluto was demoted from being a planet to being a dwarf planet. And Pluto is actually a lot more like some of the things out in the outer belt of the solar system called the Kuiper Belt, which is where a lot of comets live, most of their lives out there in the Kuiper Belt. But Mars is a planet, and we have an image here of Mars, and we're going to actually talk about this quotation from chapter 1, section 6. If the planets were much further away than the distances that they are now, the tiny amount of light they reflect from the sun, that's how we see them. They don't generate hardly any light of their own. It would not be visible to us. Matter of fact, you can't see Pluto by naked eye, and I'm pretty sure you can't see Neptune and Uranus by naked eye, but Jupiter, Saturn, Mars, Venus, and Mercury, yes, you can. And Uranus and Neptune, there's a really great... Raise your hand if you watch Netflix ever. Raise your hand. Come on, raise them high. I want to see how many people. There's a bunch of you that don't watch Netflix. Incredible. You're not admitting to it. I had a guy did his student evaluation, student perception of instruction. Boy, did he hate my guts. He said, Dr. B, he said all these bad things about me. And then he said, yeah, this class, and it was Astronomy 22, is a great opportunity to catch up on my Netflix. Unbelievable. Anyways, there's some cool stuff on Netflix about the planets. And I'm going to try to, as soon as I figure out how to link into Netflix, I'm going to share those with you. Some nice educational things at Netflix. I sound like somebody's parent. You got to watch educational stuff, educational channels. Anyways, there's some pretty good stuff in there. APOD, that's astronomy picture of the day, and they actually have views of Earth and the moon from Mars's viewpoint, and we're actually going to look at that right now. And again, it gives you an idea of the scale that we're working with when we're looking at even just planets in the solar system. If you know, when you're out and you know, on a clear night and maybe outside of town, if Mars is up, you know, it's not visible all year, but if Mars is up above the horizon, you can see it, and you can see that it's red by your naked eye. And a bunch of stars, you can see that they're actually red by their naked eye. It's incredible to think about. As far away as Mars is, you know, millions of miles, you can see that it's red by your naked eye. So let's take a look at some of this stuff. We're going to look at the Earth-Moon system from the surface of Mars. And how we're going to do that with the Curiosity rover. Here's a picture of it in Houston while they're putting it together and testing it. I like this picture. Look at this guy over here. You know, all our government, where's my cursor? All our government tax dollars at work. This guy's just standing there looking around. I don't know. Anyway, so most of the rovers that we prior to that were pretty small. We have put some landers that didn't move around, but before this one, we had some rovers that were pretty small. You know, like maybe a tenth the size of that. This one's pretty big and nice. So it's like a pickup truck for size. You know, when it's all folded out and everything like that. All right, now, I want you to look at this picture carefully. This is a real picture from the surface of Mars of Curiosity. Notice anything about that picture? What did you notice? I heard you laugh. I saw you laughing there. Did somebody say what they noticed? No? No? What do you... Okay, in the fourth row back, what do you notice on the aisle? Yeah. Was there some little Martian guy up there doing a... Look at that. How'd they do that? You know what they did? See that machine? It's got about 17 cameras on it, right? So what they do is they take a series of selfies and then they piece them together into it so that you know. And those guys at Jet Propulsion Lab, JPL, which is the base for these rovers and stuff. Those guys are experts at sewing together. You know, Photoshop is like child's play for them. You know, they got software out there that make your eyes water. And so that's how they did it. The Curiosity took a bunch of pictures of itself with several different cameras, and they put it all together like that. The little reflection? What little reflection? There's a... Oh my God! It is a Martian! No, that's a reflection. You mean right up here?
Yeah.
Yeah.
It looks like it's... when I saw...
You know what it looks like? It looks like the shadow. You know what that looks like? The shadow of...
Like the lander or something?
Yeah. It looks like... No, it looks like the shadow of this. See, look, it's got a shadow underneath it. And you know what I was looking at? Look at these two patches down here. They couldn't get it perfect. See these two kind of bluish gray patches here? And I'm sure if you look at the shadows, they don't all work out. And this probably doesn't work out. But it's kind of a nice picture. Anyways, let's go to the target destination, a place called Dingo Gap near Mount Sharp. Okay, so this is a wide-angle lens picture of a sand dune, and you can see a little bit of the rover down here at the bottom of the picture. Here's another look at it. Okay. Now these meter sticks, that's a 2 meter stick over here, sticking up straight, and this is a 2 meter stick here, 200 centimeters. And this is, you know, those rulers, of course, are, you know, superimposed on the image, but this is like what you would see. Let's get a little closer. All right, this is the gap. All right, so this rover went through the gap. All right, here's some of its footprints. It's on the way, on the other side of the gap, inside the gap. And you know what look at this thing carefully. Notice anything interesting?
Tracks.
Yeah, we definitely got tracks. So we're not trying to trick anybody with this. This is, you know, just looking back. Turn the cameras, look where you went, where you came from. Notice anything else in there? Anybody here from the Caribbean? Okay. Anybody here from the Virgin Islands, the Caribbean? All right. Where are you from? BVI's? Did you ever fly in and out of the Cyril Lee King in St. Thomas? Yeah, the airport. Notice anything? Look at those blue rocks. The only place I've seen blue rocks like that is in St. Thomas in the Virgin Islands. It's a volcanic rock. These are volcanic rocks. And the volcanic rocks at the end of the runways, you probably looked at it a million times, but you never notice how blue they are. But you fly down to St. Thomas in the U.S. Virgin Islands, you know, the plane comes in from the ocean and it lands, and at the end of the runway, you're looking at this cliff, which you stop before you get to it. But the cliff is this volcanic formation. It's a beautiful bluish green color. It's very rare on Earth, but here on Mars. Now, this is what they look at nightfall. Turn the cameras. They looked towards Earth. Here's what they saw. Can you see Earth? Take the lights all the way down. Let's get the lights down to zip zap. Can you see Earth? Can you see it? All right, lights up to 50%, please. Raise your hand if you can see it. You think you can see it. All right, for the rest of you guys. Yeah, that's it right there. See, and that looks like, that's like us looking at Mars. Mars is not that big, but it's steady. The planets do not twinkle. The stars twinkle, but planets are close enough and strong enough that they don't twinkle. All right, so that's Earth. And actually, this is what they're looking at. It's actually two blips, Earth and the Moon. Now, I want you to see if you can make a sketch of this. And let me help you out. Here's a vertical line from North Pole approximately to the South Pole. You see, you can see weather patterns. You know, that camera on Curiosity can actually see, you can see weather on the surface of Earth from Mars. Pretty sweet. So that's a line basically from North Pole to South Pole. And here's one. I moved it a little bit to the right for the Moon. All right. So go ahead and kind of sketch that in. Now, here's another line perpendicular to the Earth, the red line between North Pole and South Pole on Earth. Just draw an arrow and say, okay, the sun is out that way, because that's the sunny side of the Earth, right, from this picture. So you're looking at Earth from Mars, and so you're not in line with Earth. You know, Earth's over here, the sun's over there, and you're over here on Mars, and you're looking at the Earth. And so off to the left a little bit in that picture is, and in the picture, the sun is down, right? It's sundown. It's after sundown on Mars when they took a picture. And so somewhere off to the left, but Earth is still reflecting the light, you know. And that's how we see Mars, you know. Mars, when we can see it, is always facing inward to the sun. So it's never, we never see Mars like this. Then the moon. Now, down here on the moon, kind of trace lightly the shadow. That's the, on the dark side of the moon, that's where the shadow extends out. And so I made it taper a little bit, kind of taper off to the left. And notice that this shadow it extends away from the sun, out to infinity, but it definitely does not hit the earth. The moon, at this instant of time, when Curiosity snapped this image with its cameras, the moon was not causing an eclipse. And why is that? Because it's kind of down. Its orbit takes it below the Earth, and so there's no eclipse. Now, and so what this tells you is that the orbital plane of the Earth around the sun is like this, and the orbital plane of the moon around the Earth is a little bit tilted with respect to that. So sometimes the Earth or the moon is below Earth's orbital plane. Sometimes it's above. And if it's above or below, it's not going to cast a shadow on the Earth. And so no eclipse. All right. Now, last comments are about the sun's place in our galaxy. And they make a mention. Yeah, we're about 30,000 light years from the center of the galaxy. And I don't know if I would write this. They say that our location in the galaxy, nothing much to distinguish it. I beg to differ, but that's what they say. I think we live in a nice neighborhood. But the center of the galaxy, oh my goodness. Very interesting, because at the center of the galaxy is an enormous black hole. It's called SGR A star, Sagittarius A star. And we can't really see it, but we can track, you see this oval, this ellipse you see in the image? That's a star that we can observe. We've tracked it now for a couple decades. This is from a paper back in 2002, I think. And they finally measured the mass of this black hole from measuring the orbit of this star. It's called S2 in the center of the galaxy. And you know how they see it? They see it through infrared. They can't really use visible light. So red, orange, yellow, green, blue, indigo, violet. It's kind of hard to see down into the center, but infrared, yeah, we can see the center of the galaxy. Radio waves too. Several million times the mass of our star. So yeah, we're 30,000 light years away from that, and it's unimaginably violent at that black hole. And these stars are orbiting. They're fairly safe. They're still far enough away that they're not going to get sucked in anytime soon, unless something happens. But yeah, it's a black hole. And just make a note, when we get to black holes, we're actually going to be talking about this one a lot through the semester, but we're going to get back to it when we talk about black holes during Black Holes Week, the last week of the semester. So, the proportions, we can actually measure, matter of fact, these measurements up here, you're going to understand everything in here and be able to compute period, eccentricity, and semi-major axis. You're not going to be able to do inclination because it says 46 degrees, because that involves a lot of trig, pretty fancy trig too. But the other ones, yes, you're going to be actually able to do that. It's a great example of some of the things that Kepler and Sir Isaac Newton and Galileo figured out about the planets moving around their orbits. Go ahead.
Yeah, I just have a question about black hole, because if it would have to orbit in a
No, you can have, there's a zillion different kinds of orbits around in a gravitational system. You know, our orbits around the sun are actually ellipses, but they're very close to being perfect circles. But you know what's not a perfect circle? Comets and some of the asteroids, they're pretty elliptical. You know, they're very eccentric. But the planet, even Mars, it's hard to distinguish it from a true circle. But in the center of the, you know, there's nothing that says a star can't orbit a black hole on an elliptical orbit. It's, you know, it's fine. You know, the black hole, this one's probably spinning, so it's not a perfect sphere. Maybe that's what you're thinking of. But yeah, it's possible to have a spherical black hole. This is probably spinning a little bit. They're still studying the heck out of this baby. It's the closest galactic black hole. There's another one in the Andromeda galaxy. Some people think that there's a black hole in the center of every galaxy. Kind of interesting. Big mystery. We're still trying to figure that out. All right, I have another clicker question for you. You should still be on multiple choice. Hit your refresh key if you're still waking up. This is just like a mental IQ test question. True or false, space is mostly empty? If you did your reading, you know the answer to this. 15 seconds to vote. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, 65% of you answered correctly. Yes, space is not mostly empty. It's got a lot of stuff in it. So here's a little pull quote from 1.6. The space between the stars is not completely empty. It contains a sparse distribution of gas, mostly hydrogen, intermixed with tiny solid particles that we call interstellar dust. And I asked you about that directly in the homework, so that was actually a homework question. So if you did your homework, you know about that. But now I'm going to give you a little bit more instruction to amplify on that. What is this stuff that we call interstellar dust? Boy, there's a lot of stuff. When we look at interstellar dust, we see a lot of different compounds. And I mentioned that every compound under the right conditions will produce a spectrum, a discrete spectrum of some kind. Maybe in the infrared, maybe in the ultraviolet, maybe in hard X-rays. But it'll produce a spectrum, maybe in red, orange, yellow, green, blue, indigo, and violet, what we call the Roy G. Biv colors, visible colors. We have seen a lot of different compounds in space. And one of them it always amazes me. You know, I'm not really strong on chemistry. Raise your hand if you've had chemistry class here at UCF. Yeah, everybody that just raised your hand is smarter than me at chemistry. But yeah, pyroxenes. Now basically we know how to spot all these chemical elements by looking at spectra and studying them very carefully, making very careful measurements, just like what we did. And to figure out the identity, you have to take several measurements. You got to do a bunch of trig. But it's not that bodacious. Even an undergraduate like you guys could do that if you had a little bit of trig. And actually, just knowing Pythagorean theorem probably could do it. But pyroxene, go ahead and write down the word pyroxene in your notes. It's a class of chemical elements, compounds, I should say. Here's one kind of famous pyroxene compound, NaAlSi2O6. It's also known as jade. Can you imagine that? You know, looking through a telescope, and you're analyzing the spectra, you know, a bunch of wiggles on a chart, and you work it out. I'm looking at jade, 200 light years away, or wherever it is. It's amazing. Jade. So this is the chemical formula for the mineral here on Earth that we call jadeite. And I'll spell that for you. Jadeite. Jadeite. And there's another kind of jade called nephrite, but that's a different, I don't know, they might have found nephrite, but yeah, the pyroxene jadeite. So we see stuff like this in space. So my wonderful students, space looks empty, but oh my goodness, it is not empty. And it gets even more interesting. Here's another thing that we can see. Stuff like glucose. We can, and the interesting thing about glucose, sugars, biological origin always has these chemical compounds, these molecules have what we call chirality, handedness. Biological origin, always right-handed. We never see, we can make it in the lab, left-handed glucose, but if you have something, and you know, here in our planet, you know, when you're eating something, so the other name for D-glucose is dextrose. You know, that's a biological origin. And L-glucose, the left-handed glucose, we can make that in the lab. But you can see, look at that. Look at that molecule. And you can see that it's not symmetric. The left and right side, you can't flip it and get the same image back. It'll look different. Amino acids. Biological origin, always left-handed. Nobody knows the reason for that. But we know, you know, by observation, right-handed. And third comment, left-handed or right-handed molecules, the reason that we know that, the reason we classify it, is because these molecules, whether it's dextrose or some kind of amino acid, when we pass light through it, you know, we put it in like a beaker or actually a rectangular container and pass a beam of light through it, it makes the beam of light rotate to the counterclockwise or to the clockwise. And that is why we say that some molecules are left-handed and some are right-handed. And it traces back to their structure, which is not symmetric like this picture. So there's a lot of interesting things, just a lot of interesting things to think about. You know, the phases of the moon and lunar eclipses and stuff are pretty interesting, but space is not empty, my friends. There's a lot of interesting things to learn. Now, I'm going to dismiss you a few minutes early today. Homework 2, I have it set up as a reading assignment, so it's Homework 2 HQ, headquarters. Do that reading and get started on that for a Thursday lecture, and that'll be it. So a bunch of reading assignments. Okay, you're dismissed. I'll see you on Thursday.